Okay, on number 6, we have a second order linear ODE of the form. In this case, the form that you're looking at is that this x has the same power as the order of the derivative. So you have an x squared times the second derivative of y, and you have an x to the first times the first derivative of y, and then you have no x's times y itself. We're going to look at this type of equation later on in the course. But essentially you can solve them by using the substitution y is equal to x to the m, and substituting in just like we did on 4 and 5, and then solving for m. So here for a second order ODE, we need to find the second derivative, first and second derivative of y. And so if y is equal to x to the m, see if I can get my pen isolated, y equals the second derivative, or y equals x to the m power. To get the derivative, here you carry down the power m, and then you decrease the power of the exponent by 1. That's just like if you have x to the 5th power, you would carry down the 5 and then decrease the power by 1 to give you a 4. The second derivative, carry down the exponent. So here we're carrying down m minus 1, gets multiplied by m, and then decrease the power by 1. So our new power is m minus 2. And we want to substitute into this equation, and here we're given values. So we want to use those values to solve for our constants. But first we'll substitute into the equation. So we'll start x squared times the second derivative is m times m minus 1 times x to the m minus 2. Then I have minus 2x times the first derivative, m times x to the m minus 1. Then I have minus 4 times y, x to the m, is equal to 0. Now, we want to take these powers of x's and we want to combine them together. If I have x squared and multiply it by x to the m minus 2, we're actually adding the exponents, and this positive 2 and that negative 2 will cancel each other out. It'll leave me with x to the m. So it's going to leave me with m times m minus 1 times x to the m. Then I get minus 2, and again here I want to combine my x's together, and the 1 that I have as an exponent for this x and the minus 1 up here again will cancel out. It'll leave me with an x to the m. So here I get 2m x to the m, and then here I have minus 4x to the m. And notice that I have this x to the m in common. We could factor it out. Factoring out the x to the m leaves me with m times m minus 1 from my first term, leaves me with a minus 2m from my second term, and then minus 4 from my third term. And here inside the brackets you want to simplify. You want to distribute through by the m to give you m squared minus m and then combine these. Negative m and negative 2m will give you a negative 3m. If possible, we want to solve by factoring. M squared minus 3m minus 4 can be factored. into m minus 4 times m plus 1. And if you set your factors equal to 0, you get m is equal to negative 1. Whoops. M is equal to 4. Or from here, x is what we're solving for. The only way you can get 0 as an answer is if x itself is equal to 0. And we're actually solving for m, not for x. If x is equal to 0, you're going to get a solution of y equals 0, which is a trivial solution. And you don't really want to consider those cases. So we have m equals 4, which gives me one solution, x to the 4th power, and m equals negative 1 gives me another solution, x to the negative 1st power. So in this case, my general solution is going to be y equals c1 x to the 4th plus c2 x to the negative 1st. Now, because I'm given values, I can solve for c1 and c2. If I substitute in here y of 1 equals 0, here I'm substituting 1 in for x, and that's going to give me c1 times 1 to the 4th plus c2 times 1 to the negative 1st. 1 to any power is 1. So I just get 0 equals c1 plus c2. And for this second equation, I need the derivative of y. Let me do that up here. If y is c1x to the 4th plus c2x to the negative 1st, then I'm going to get y prime equals 4 c1 x to the 3rd minus c2 x to the negative 2nd. And then substituting 1 in for x, 1 to any power is 1, is just going to cancel out those x's. So I get y prime of 1 goes here. Y prime of 1 is negative 5, is going to give me 4c1 minus c2. And here we can just add equations together because the c2's will cancel each other out, and we'll get negative 5 is equal to 5c1. That tells you that c1 is negative 1, and because c1 plus c2 is 0, we know that c2 has to be 1. Negative 1 plus 1 is 0. c2 is 1, and so our particular solution is going to be y equals c1 is negative 1, negative x to the 4th, plus c2 is 1, plus x to the negative 1st.